These are brief notes on section 6.1, which is finding the area in between two curves. If we have the graph of two functions, so my top function is here, let's call that f of x, and then we have another function that looks like this, that's g of x, and we want to find the area in between those two, so we want to find this area right here. First thing we would need is we would need to find these two intersection points. Let's call those A and B. If I integrate f of x from A to B, it would give me this much. So it would give me all of this. And if I integrate from A to B of g of x dx, that would give me this much. So notice if I have all the purple area and then I take out the red area, I subtract out the red area, I'd be left with this area right in here, which is what I'm looking for. So to find the area in between two curves, what we're going to be doing is we are going to integrate from intersection point to intersection point of whatever the top function is, which in this case is f of x, minus whatever the lower function is, g of x. So f of x minus g of x dx. That gives us the area in between those two curves, assuming that f of x is greater than g of x. If g of x is the top function, then it would be g of x minus f of x. It does not matter if both functions are above the x-axis like this, or if both functions are below the x-axis like that. It's still top function minus bottom function. If that's f and that's g, we would be doing f minus g. Or if one function's above the x-axis and one's below, something like that, you would find your intersection points, top function minus bottom function. So let's look at an example here. Let's let f of x equal 2 sine of pi x over 6 minus 3, and g of x equal negative x squared minus 4x plus 3. So go ahead, graph that on your graphing calculator. These problems, more often than not, are calculator problems. Make sure you're in radians mode when you graph it. Your graph should look something like this. That sine curve is right down here. And then the quadratic looks like this. So first thing we need to do is figure out where these intersect. I need that point and I need that point right there. So calculate those intersection points on your graphing calculator. Go to calculate, which is second trace. Go to number 5, which is intersection. It'll ask you first curve, second curve. We've only graphed 2 curves, so just push enter, enter. It'll ask you guess. Whatever you guess, whatever your guess is, it's going to give you the closest one to that. You should find that the left intersection point is at negative 5.277. Let's talk real quick about showing work here also. When we're finding the intersection points, what we're doing is we're looking for the values when the functions are equal to each other. So you don't need to show a lot of work here, but at least show what you're doing when you're finding the intersection points. So you could write intersection points are, or f of x is equal to g of x at x equals negative 5.277, and find the other one. So we do it the same way, second trace, number 5, intersection, first curve, second curve should be the same ones. When it asks you to guess, this time make sure you're closer to the one on the right there, and I get exactly x equals 1. And now we're going to set up our integral. We need to integrate from negative 5.277 to 1. of the top function minus the bottom function. Notice the top function here was the quadratic. It was the second one that your calculator graphed, which is the g of x. So this time we're doing g of x minus the bottom function, which is f of x. Make sure you have g of x minus f of x in parentheses. Make sure you have your dx here. And then on your calculator, go down to y3. And under y3, graph y2 minus y1. To pull up y2 and y1, you push alpha trace. Alpha trace will pull up that screen. So under y3, we are graphing y2, because that's g of x, minus y1. Make sure you turn graph 1 and 2 off. Under y equals, highlight the equal sign and push enter so that it is no longer highlighted on both y1 and y2. That way only y3 gets graphed. And then calculate the integral. Second trace to pull up the calculate screen. Number 7 is the integral. And type in your bounds. We are going from negative 5.277 to 1. And I get an area in between those curves of 48.897. 48.897. We always round to the nearest thousandth. If you happen to get a negative area, there's one of two things that you probably did. You probably either switched these, they're in the wrong order. You did f of x minus g of x would spit out a negative value, or for some reason you typed in your bounds backwards.